Welcome, everybody. It's just brilliant to have so many people here to see Shuchi. And in fact, we've got to say welcome back, Shuchi, because she presented in our very first seminar series, which we think might be 5 years ago. Anyway, this is our first seminar of 2025. My name's Jane Waite, and I'll be chairing the session today. I am so excited to be kicking off this our brand new seminar series where we're focusing on teaching about AI and data science. And in this series, we're going to be exploring the research that examines what students might learn about AI, machine learning, and data science, as well as how we might teach it, what the most effective ways are to teach these critical topics in schools. And as I said, I'm very excited. We're really thrilled and we're very grateful for Shuchi coming along to come and talk to us about not only teaching about, but also a bit as well about teaching with. So thank you for joining us. I hope you're as excited as I am to dive into this new series. I'm really, really pleased to welcome Dr. Shuchi Grover who is the Director of AI and Education Research at Looking Glass Ventures in Austin, Texas. So she is a computer scientist and learning scientist with over 20 years of experience in K-12 computing education, and that's both formal and non-formal. And she's led numerous National Science Foundation funded projects focused on designing and researching curricula, assessments, and tools to develop 21st century competencies in computing, AI, data science, and cybersecurity. In her presentation today, Shuchi will explore the dual role of AI in K-12 education as both a teaching tool, that's teaching with, and as a subject for literacy and understanding, so that's teaching about. And she will be discussing how Gen AI can be ethically, I think that's so important, the ethical issues to support STEM and CS learning, and how foundational AI literacy concepts and ethics can be integrated into curricula. So with no more to do, it's over to you, Shuchi.
So that's the title of the presentation. Lots to cover from what you heard from Jane. But first of all, thank you so much for this invitation once again, and to you and to the Raspberry Pi Foundation and everybody that makes this amazing seminar series happen. So I'm joining you from cold and freezing Austin, Texas, where I woke up to rare views of a sprinkling of snow this morning. As you know, it is in the southern part of the US, and we rarely ever get to see snow here. So that's us. For those posting their temperatures from Wisconsin and elsewhere, Austin isn't much warmer. So a quick roadmap, we look at this AI moment and then look at teaching with AI, which is AI in education, and about AI or AI education, and then a few closing thoughts. What I'm going to share today is shaped by experiences on two recent NSF-funded efforts on designing AI learning that I led or co-led, a 4-year effort called CS Frontiers that focused on engaging high school girls in CS, including AI, and AI and Cybersecurity for Teens, a 2-year exploratory effort where we focused on integrating AI and cybersecurity. And a recent NSF-funded effort, which was aimed at understanding teacher and generative AI teaming, examining high school mathematics teachers' experiences, working with custom LLMs to generate complex classroom assessments. I may not go too deep into this. We'll see how much time we have to go into all of this. Some of my perspectives also come from other projects and efforts that I advise, like Teach AI, a large global consortium supported by the World Economic Forum, as well as the Generation AI project in Finland that is led by Martti Tedre and others. I also just completed co-authoring a fairly comprehensive brief on AI in STEM teaching for Cadre, the DRK-12 NSF Resource Center. And this is hot off the presses. This URL was released just about half an hour before this presentation. And I also help produce briefs on ethical AI research in education and AI in STEM learning. And lastly, I also draw on this paper that some of you may have read. It was published at last year's CS Education Conference, SIGSE, at Portland. All right, so let's talk artificial intelligence. It's everywhere. Chatbots and large language models have captured everybody's imagination in a way that nobody foresaw. And AI has just dominated ink and pixels in news articles for 2 years. There's been a nonstop deluge of LLMs and AI and how they are transforming the world, and progress is happening at this dizzy pace. There's excitement, but also many reasons to be apprehensive. Sometimes there's a feeling of hopelessness against this oncoming juggernaut, but that has not stopped all this buzz around AI in education, as well as AI education itself, which includes AI literacy for all. And many, many headlines have been devoted to teachers and how students and teachers are grappling with this new reality. And in this context, a recent US Office of Civil Rights report that was released, I think, was a very important document. It lays out scenarios and case studies which involve discriminatory use of AI that schools or entities could be held accountable for, even if it is sort of, relegated to the background with the new administration. I think the document is relevant and will remain relevant for us. So even as this ongoing debate is going on about whether AI is good or bad, it cannot be ignored. The reality is that these are very powerful tools that are capable of amplifying human intelligence, as visionaries had imagined 60 or 70 years ago. Starting with this ambitious Dartmouth summer research project on AI in 1956. And if you read the text, it really looks very ambitious. They wanted to talk about how machines use language, form abstractions and concepts, solve kinds of problems now reserved for humans. And they think that a significant advance can be made in one or more of these problems if a carefully selected group of scientists work together on it for a summer. And this is the gentleman who we need to credit for the term artificial intelligence. That's John McCarthy. But of course, the idea is even older than that. It's a good time to rewatch The Imitation Game with Benedict Cumberbatch in his award-winning role as Alan Turing. I'm not going to play the video in the interest of time, but can machines think is a very relevant question today as people struggle to describe and distinguish generative AI capabilities from those of humans. And this is the paper, of course, the 1950 paper that described the Turing test, a test of whether a machine can pass off as a human in a chat exchange. So while AI has basically been around for as long as computing has, its progress has not matched that of general computing. Since those early days in the 50s, AI optimism has gone through many peaks and troughs. And although the trajectory right now looks like it's shooting upward, there may well be a plateauing or even a downturn somewhere in the future. So a healthy bit of skepticism may not be unfounded. But one thing that I do appreciate about this current AI moment is that it has forced us to pay more attention to what it means to be human. And the study of AI is really a study about human intelligence and what it means versus a machine. And so at the school level, we need to help students and educators understand that it's not the future. AI is the future is wrong. It's here and now. It's not monolithic. It's now an integral part of how our world works, or for many of us. Not magic. It does not happen without humans. It's not always accurate, not always reproducible. There's a margin for error, especially with today's LLMs. It's not perfect. It has biases. And it's neither good nor evil. It's really how people generate and use AI. And for those of us in computer science education, it's important because it's engendering new paradigms of programming. And so we cannot leave AI out, as a lot of tech tools today don't follow the classical programming paradigm anymore. And some believe that just like access to the internet and computers were in the past, who gets to use and understand AI could fuel the next digital divide. My own view is that maybe the hasty versus thoughtful deployment will also likely engender an AI divide. But it's our responsibility to ensure that children are well equipped to understand the world that we live in, and computing and AI are a big part of it. And knowing and understanding something makes you that much more a better consumer, a smarter consumer of that tool or technology. And so education truly is the best strategy for thriving in a world with AI. and a good inoculation against its misuse. So when it comes to K-12 education in the age of AI, we're talking about two things. One is, of course, teaching with AI, which is patently about using AI tools in the teaching and learning process. And the second is AI education, or teaching about AI, which encompasses the foundational AI literacy for all, as well as what AI looks like in computing education. So let's look at the first one, teaching with AI. Now, AI in education is not new at all. Like I said, the goal of this graphic actually is to underscore that AI in education has progressed in parallel with the progress of AI itself. The most prominent AI in education efforts in recent memory took off in the 80s and 90s. They were centered on cognitive tutors and intelligent tutoring systems. They had little adaptivity in the beginning. They were initially based on the behaviorist model of learning, where individualization was really a matter of how you're pacing. But then as computational tools became more sophisticated, there was increasing adaptivity. It spawned new subfields at the intersection of CS and education, education data mining, learning analytics, etc. And then the clickstream of big data from digital environments coupled with computational analytics meant more adaptivity and personalization, which meant increasing attention to socio-emotional factors in learning, looking at things beyond log data to speech, facial expressions, gaze, and gesture, and to support not just individual learners, but collaborative learning, and increasing attention to support rather than supplant teachers in the classroom with teacher dashboards and combining teacher knowledge with predictive analytics. And it's increasingly become more human-centered as focus on educational equity has increased. But all of this required adoption in classrooms. This is the pre-Gen AI world. It required adoption, which meant planning, funding, stakeholder buy-in, professional development. And that's what contrasts it from what generative AI has been. It wasn't adopted, it's arrived in everybody's hands, directly in the hands of students and teachers. And it's more general purpose, whereas all those other systems were much narrower or narrow AI. And it's embedded in many tools that teachers and students already use in everyday life and even in the classroom. Think about Google Classroom and Gmail, etc. So this recent AI in STEM teaching brief that I authored, we examined some recent NSF-funded, National Science Foundation-funded efforts. And here's a sampling of how teachers or how research is envisioning the use of generative AI in STEM education. So constructing, training, and fine-tuning a generative AI LLM chatbot to assist teachers in developing culturally responsive curricula with a focus on ethic of caring and respect, using natural language prompts, having a math LLM generate technology-enhanced interactive formative assessments that required coding at the back end. That's my project. An NLP digital assistant for teachers to provide assistance in tailoring lesson plans according to their goals and student characteristics, AI image generators that could provide a hook into the lesson that may not have been available otherwise, an AI instructional assistant engaging other students in class in topical conversations while a teacher is engaged in person with other individuals or groups, an NLP-based tool that gives instructors feedback on dialogic instructional practices. So this is during teacher PD and helping teachers understand how to, the uptake of student contributions, talk time, etc. Classifying students' expertise levels in scientific explanation, human in the loop NLP to NLP is natural language processing, by the way, to automatically score short answer questions, informative assessments in a curriculum integrating science, computing, and engineering concepts, generative AI and LLMs serving as virtual facilitators, providing feedback to math teachers during PD. So this is a project that I was involved in. I'm not going to go into too much detail since we want to get to the teaching about AI part. But one of the things that I want to just share is this finding that there are several factors that impact a teacher's use of an LLM in the classroom. It's their context and classroom environment. It's the teacher's background and attitude toward AI in general. It's the learning curve with respect to prompt engineering. It's whether or not they view generative AI as a thought partner. alignment with their teaching philosophy and business as usual, utility and functionality without, what generative AI brings to the table, basically, and how they're able to engage students in this process of using AI in the classroom. And we had a recent AI summit of all the projects, one-year projects that were funded by the NSF, of which mine was one. And these kinds of findings actually overlapped with the findings that many others had as well. And so, unless LLMs attend to these kinds of issues, they're not going to be successful in classrooms, I think. It's an alignment issue that we need to care about. Staying on the theme of assessments for a bit, there's been a lot of talk about, cheating, etc., given the amazing capabilities of AI, LLMs producing essays and code and answering questions. And, these approaches are being taken currently, but it's clear that we have to move to adapt and embrace. These are from a presentation that Mike Sharples had made. AI detectors, plagiarism detectors don't really work. And so what we really need to do is rethink assessments toward more authentic assessments, focusing on process rather than product, establishing guidelines on the use of AI for students, etc. And there are several guidance documents that have come out everywhere, including this one from the Office of Education Technology last year and this one from UNESCO. So in this brief that we had written, there were some other questions that emerged for LLM use. And I think these are very generic, whether you're a CS teacher or a STEM teacher or a non-STEM teacher. Can an LLM be fine-tuned for a specific topic or context? And how might you do it? How might we design teachers, tools to give teachers the agency and control to do this? What pedagogies and cognitive models of student learning are encoded? We need to know that. And fix that if necessary. Whose language and worldviews are being privileged? How should biases be addressed? How can we promote rather than hinder culturally relevant designs? Because we know that already racial and cultural biases have been demonstrated in image generators and speech recognition. Which model should be used for which task? There are so many out there, and models are untested yet, and they misinform. How can we leverage things we know from learning theory and research? How can situational awareness of a classroom be incorporated? And how can we center teachers and learners in the social culture of the classroom and the communities in which learning happens? When it comes to student-facing personalized learning, we feel like we are closer than we have been ever before to achieve this goal of providing real-time support to students with a tool that engages in conversations that help reveal their thinking and assist them in their learning, prepare learning pathways that are customized to learner needs. You can think of an individualized education plan for every student, empowering students by offering diverse learning opportunities, maybe creative production of learning materials by learners themselves, given that these tools are so good at that. Foster interest-driven learning across space and time, engage in culturally appropriate pedagogical practices, including language customization, especially for students from non-dominant cultures, and support students with disabilities or other specialized learning needs, and otherwise, in general, augment teacher capacity and address teacher shortages, especially in resource-constrained contexts. But there are several potential pitfalls. There's a danger that machine learning models may misclassify or misdiagnose learners by overlooking factors such as language use, ethnicity, and prior experiences. They may exacerbate inequities and biases toward learners from different racial and cultural backgrounds. And this is especially a possibility because LLMs have been trained on data from the internet, which is grossly skewed toward Western English-speaking sources. They may not be appropriately responsive to wide-ranging needs of students. We know learning is not simple, and teaching in a diverse classroom is not a simple task. Track or pigeonhole students into limiting paths based on biased data, learner isolation, loss of human relationships, and basically a corrosion of the social climate of the classroom, all of these last three being so key to learner well-being. Now, in addition to personalized tutors, Mike Sharples created this table of many other roles that generative AI could play that appeared in that one of the first guidances from UNESCO on ChatGPT. It could be a Socratic opponent, a collaboration coach, a guide on the side, a study buddy, a co-designer, etc., etc. But whatever role the generative AI takes, it's important to remember some very key things from the learning sciences. Learning is at its very core social and cultural, in addition to being situated and contextual, as well as values driven. And there's already a huge body of research on designing learning that takes into account these characteristics of learning. So AI systems need to take that into account. Any AI in education system, needs to be context sensitive, and it has to support and adapt to specific learning environments and contexts in which they're being used, offering relevant supports and tools. And this context awareness has to extend to learners' interests and backgrounds and prior experience and ability, etc. They need to be culturally competent, provide cognitive scaffolding in an appropriate way, support collaboration, be sustainable, accessible, and affordable, and be trustworthy and responsible. And currently, I don't believe there are any LLMs or AI tools that come close to actually capturing all of this. And such work requires interdisciplinary expertise in learning research, social sciences, ethics, AI, CS, data science. And so we need to, have educators and education stakeholders partner with EdTech to develop good educational AI, or, I'm sure researchers do this already, but it's never large scale. And what really enters the classroom more quickly is what is developed by the, technology industry, EdTech industry. So we need to sort of make sure that they develop good educational AI and build models based on good pedagogy and inclusive education. So given this audience, I cannot talk about AI in education without at least briefly touching on AI in CS education, especially with respect to learning of programming, which has been such a huge topic of our research all these past years. So ever since coding capabilities of ChatGPT were first revealed, people started talking about the end of programming. But then since then, there's been a little bit of acknowledgement, even by people at Google, that learning to code still remains relevant. But there's no doubt that there is a changing reality that we must all confront. And this is because LLMs have become remarkably good at producing code, including code for block-based programming environments. So this is the output from ChatGPT when I asked it to produce code for the rock, paper, scissors game, which turns out to be a very popular exercise in K-12 when students learn conditionals. And even though it doesn't produce the block code, it provides detailed instructions of how to create and set up sprites, the variables, what code has to go into each of them. It even provides nice headers like code for determining the winner, etc. And just yesterday, I saw a tweet on X, post on X, which demonstrated how well an LLM can take a Scratch image as an input and produce an explanation and provide suggestions on how to improve it, etc. And since I work a fair bit on projects involving the integration of coding and computational thinking into STEM learning, I decided this was about a year ago to experiment with computational and agent-based modeling exercises. And lo and behold, within seconds, you can produce well-documented Python code along with instructions that are not shown here on how to run it in the terminal on Mac to actually have a simulation of the temperature, pressure law, etc., etc. And I did many more improvements to this model. And in response to this very simple prompt, create a multiple agent-based tool model that models bacteria and the relationship between bacteria and antibiotics. And it produced this wonderful agent, explanation of models, the components and behaviors, the pseudocode. It even says that you would use an environment like NetLogo, which is well suited for agent-based models. It produced explanations of each step and extensions, etc., etc. And so in this era of prompt-driven programming, clearly we need to de-emphasize producing code. Students need to understand what's known as code sense. As Maggie Johnson of Google recently put it, she likens code sense to number sense. And she says it's a conceptual understand, just like number sense is a conceptual understanding of numbers and how they're related and connected. Before we can move on to, algebra or calculus, we need to develop code sense to be successful in this new era of AI-assisted programming. And Teach AI has this definition, that it's a conceptual understanding of the computer's program, of a computer program's underlying design, processes, and system relationships, mental capacity to analyze, simulate, and predict a program's behavior, and code sense supports the ability to debug effectively, optimize performance, understand the broader context of the code within a system. So coding is essentially in the classroom becoming more like a software engineering exercise, because you can move one level up in abstraction. You can build much larger systems, I think, even at the K-12 level, because kids can be taught to think about what the components of the system are, and the nitty-gritty programming can actually be done by the LLM. And I asked ChatGPT 4o what the similarity between number sense and code sense is, and it gave me this very nice output. I actually only color coded it. But one of the things that, the last one is important. It's developed through experience, and it has to be honed over time through practice, exposure, experience, rather than theoretical learning alone, which is a very important point. So how might we develop code sense? And I know that this is a deeper topic of discussion that I'm not going to go into, so I'm just touching on a few things. I have a much more on this and that we could devote, a separate conversation to at some point. But, talking through code, either teachers modeling the process or students, talking to each other, like we had artifact-based interviews or algorithmic explanation exercises, using computational thinking logic, mapping constructs to what's being modeled, having meaningful names of variables, data structures, anything that makes reading code easy, connecting functional parts of code, functional parts of the program to code chunks, fixing a problem, explaining a model, explaining the relationships between chunks of code, and activities like scavenger hunts with clues. I don't know, there's a typo there. Scavenger hunts with clues, for example, which instruction is doing this, etc. But what's clear is that it requires code reading skills and a basic understanding of CT, computational thinking, and coding. And code sense is one of those things that is also being advocated for by Teach AI in their briefs that we are creating as part of guidance on the future of CS education in the age of AI. I'm involved in advising this effort. These are the set of briefs that have come out or about to come out over the coming weeks and months. And these are actual questions from teachers that sort of prompted the writing of these briefs. These are the questions that CS teachers have and had when this effort started. So moving to teaching about AI, I hope you're doing better with time than I had thought. So it involves two things: a foundational AI literacy for everyone, which is basically a collection of skills that a person needs to understand, use, and critically evaluate AI. It ensures that students know how to use AI through applications, as well as the fundamentals of how it works, which could go deeper into computer science. And so, there is a foundational literacy, which is more around use, and then lifting the hood on how it works and actually creating those things could be tackled within the context of CS. And so when it comes to K-12 education, we have to address it all. We have to teach them about AI as a literacy for everybody. And I'd love for you all to think about what that might include and entail. And then in CS classrooms, involving AI, data science alongside CS, and integrating AI into other core subjects. And finally, perhaps as an advanced elective in the high school level or whatever. And I think what depth we go into each of these is still something that we are all figuring out. But there's a lot of focus on that central piece, which is why I'm curious. For example, if you Google AI literacy, you're going to get hundreds of hits. Everybody has created one. And well, not hundreds, maybe tens. And every entity in this space has created their own. This is Long and McGurko 2020, which I think is a very useful one. This is a recent one for educators developed by Stanford. This left one up top is digital promise. The right one here is UNESCO, et cetera, et cetera. UNESCO, as you all know, has been very active in outlining competencies that students need to develop with respect to AI. And they lay out these competencies for students and for teachers, and because teachers need to be prepared to teach these to kids. But at the core, all these AI literacy frameworks address some very key aspects. One is the general literacy piece of it, basic understanding of AI. What is it? What does it do? The relationship between AI and humans and ethics, etc. And then the more technical aspects, which involve computational thinking and literacy. How does AI work? And data literacy as well. So I'm sure you're all very familiar with this big 5 ideas that came out from AI for K-12.org about 4 or 5 years ago, that said that what students need to know is that AI, involves perception. Computers perceive the world through sensors, representation, and reasoning. Agents maintain models that they use, and then they use them for reasoning, models of the world, real world. Computers can learn from data, natural interaction. They can be agents that interact naturally with humans. That's happening a fair bit now. And of course, the big one on societal impact, that impacts society in both positive and negative ways. There's a big 5 ideas poster that's been translated into many languages. Since you are all from all over the world, I think you might want to take a look at it. But know that this is also going through a little bit of revision and relook, right now. Students must also learn ChatGPT. That ChatGPT is not the only kind of AI there is. There's many other kinds of AI. And in fact, before ChatGPT and LLMs, there was a lot of AI that's everybody was already interacting with every day on YouTube and Amazon and recommendation systems and all of that. There are many fun videos that can explain concepts like machine learning, such as this one from Oxford. I won't go into it. And many freely available tools and activities that allow students to explore things like machine learning. I'm sure you'll have heard of Teachable Machine, tools like Quick Draw, and all of these sort of build intuitions of how neural networks, etc., work. So one of the things that we've done in our work is use Teachable Machine from Google, or variants of it like this one from the Generation AI project in Finland, which goes a little bit deeper and is more student focused. And these, they afford great hands-on experiences for students to train a classifier. And it really is a lot of fun and can be done very easily. The other thing that students need to really understand is AI ethics. Because we're dealing with decision-making relegated to machine models, AI learning experiences have to involve a critical interrogation of biases embedded in AI systems that creep in at various stages of the AI generation process, not just, data and how it's collected. And in no other field, I think, is the ethical compass more relevant than in AI. And UNESCO has an ethics of AI framework. They recommend these 10 principles that were basically inspired by the core values around protection of human rights and dignity. A very nice activity to sort of bring ethics and this idea of ethics and biases to students is around facial recognition. It's a topic that students can relate to, especially because it's so pervasive, whether it's the phone or, biometrics at the airports, etc. And such an investigation very organically also leads to discussions of the surveillance state and the ways in which citizens can potentially be harmed by such technologies. Many examples of biases in facial recognition. If you have not seen or read the work of Joy Bolamwini, I suggest you can start with this TED Talk that you can show your students as well. It's very well worth listening to. There is the Responsible AI and Tech Justice Framework that came out from KPOR. And, it's about asking questions around who is creating technologies, what are their motivations, who benefits, who is harmed, who will be prepared to create and decide the future with AI, who will be left behind. And the core components of these, of the framework include all these kinds of, how to examine the technology creation ecosystem, the complex relationship between technology and human beings, the impacts and implications of technology, AI on society, how to interrogate personal usage of AI, build a critical lens in the usage, analysis, and interpretation, and how to minimize, mitigate, and eliminate harm. And these issues are really important given the catastrophic environmental damage AI technologies are wreaking, the exploitation of labor in the global south in the name of humans in the loop. These must be topics that students wrestle with. And we need to also give students and teachers a sense of agency to ask these questions and to feel empowered to shape policies, because countries are still in the process of shaping their policy. So there is an opportunity here to impact regulatory frameworks and such. For researchers planning to do AI research in classrooms, here's a great guide that it's part of the AI briefs produced by Cadre that I was involved in. This one was led by Tiffany Barnes, and it has good guidance on which overlays responsible and just AI on the IRB framework of justice, respect, and beneficence that all of us researchers sort of adhere to as we do research. That's the Institutional Review Board framework. Another key competency that we need to learn is around data and data science. There's a growing prominence of data science and learning of data practices, and it's become a key competency given its importance in machine learning. Data literacy, as we know, involves understanding of, curating, collecting, cleaning, analyzing, visualizing, and interpreting data. But now there's, an expansion of the idea to include an idea of data agency, which emphasizes people's ability to not just understand data, but also actively control and manipulate information and data flows, what data of mine can be collected, by whom, etc. And also this idea of data equity, which advocates for shared data responsibility, for fair data practices that respect and promote human rights, opportunity, and dignity. So data literacy sort of is going to be all of this now, given AI especially. So a good activity, to sort of teach students how, large data sets can be used to teach AI models is the quick draw activity. I'm sure many of you may be familiar with it. But how do we integrate conversations of ethics in this? Students first, examine, go into quick draw, they play around with it, they learn how to classify, how objects are classified using thousands of images. And then they can go into GitHub pages to examine the data set and see that Google actually captured a bunch of data when they had people, playing with this game, and they used it to train their models. But people didn't know that that data was being collected. And so you can have these discussions about what data is being captured with or without people's explicit permission, and how it's being used to train ML models. Think of all those CAPTCHA images that we still click on, etc., that are all basically being used to train models. When is it harmful? When is it not, etc. And so examination of ethics should be baked into, teaching of AI like this, rather than be a standalone piece. Now, when it comes to teaching kids about the technical aspects of AI, how it works and the role data plays, especially in machine learning, it has to be done in conjunction with CS. For the simple reason that there is no AI education without some understanding of computing, and there is no CS education today without including engagement with AI. So they'll forever be intertwined, I think, going forward, although the learning goals, and area of emphasis may be different from what they are today. So also CS education is still very key. And in this age of AI, CS education is foundational to understanding of AI. And in the past decade, CS education efforts recognize the addition that in addition to coding and CS disciplinary ideas, students need to develop practices of programming, problem solving, and computational thinking skills, which transcend programming languages and help learners engage with applying computing in multiple subjects, domains, and situations. Over time, conceptualizations of CT have evolved and expanded from Wing to Grover and P to Tissenbaum, Sheldon, and Abelson, moving from CT to computational action, and finally Coffey and Proctor making the case for including situated and critical framings in addition to the cognitive. And if you all haven't read this recent blog post, I wrote something for communications for the ACM, which happens to be one of the most read blog posts as according to the statistics that they send for November and December. But it talks about how CT is still very relevant in an age where AI can produce code. And so things like problem articulation, decomposition, evaluating solutions, debugging, etc., still remains relevant. But AI and ML are also ushering a new paradigm of programming and CT, where the old CT involved a step-by-step algorithmic thinking approach. We are now moving to a more data-driven approach with machine learning models. Not that the old one has gone, but there is this new paradigm in addition to the old one, as Marty Tedre and others have presented, in fact, at a previous RPF seminar. It's more inductive, this new approach, than deductive. It's more black boxed and non-deterministic, et cetera, et cetera. And so, these shifts necessitate a relook at computational thinking. So students now need to understand both the old rule-based CT, which powers still a lot of computing, but also this new data-driven probabilistic CT that drives ML. And building on Kafai and Proctor, we still need to have the situated dimensions that cover context, and also these critical, ethical, and justice-centered framings that prompt students thinking around the ethics, risk, and benefits of any kind of computational solution. And there are some examples of this kind of research that showcase this kind of combined work. So in the paper that I had written last year, I've shared this plurality of pedagogies that recent research projects on AI education have employed. There's explorations with pre-designed models and tools. There's digital non-programming interactives. There's constructionist sense-making, unplugged activities, APIs for classification, lifting the hood through programming models, ML models, integrating movement and cultural practices, socially relevant AI apps, co-designing with students, and ethics-focused, and also integration with other subjects. And there's citations for all of these in the paper if you take a look. So I'm going to briefly delve into a couple of examples before I close. In the CS Frontiers project, we aim to give high schoolers, especially females, engagement with emerging topics such as machine learning and cybersecurity, Internet of Things, distributed computing, basically all those topics of computing that impact their everyday lives, but they rarely get to engage with deeply as part of current CS, CS curricula. And so it's with this great team of researchers and graduate students and teachers that we piloted several, these modules. And we use Nets blocks that I'm sure many of you are aware of now. It sort of builds on Snap, the block-based programming language, and essentially opens up Snap to the internet and unleashes a world of possibilities, allowing programs to access real-world data sets and web services through one call block that has been created. And so just under science, you could be probing air quality, COVID-19, earthquake, all this real data. And the great thing is that it can extend to user-created data sets too, with students' own data imported as a CSV file. Just as a quick example, this little block of code calls the climate service, which gets carbon dioxide data from the Mauna Loa Observatory in Hawaii from 1960 to 2020, passes it to a chart drawing service, and within seconds, you have a visualization of the carbon dioxide levels from 60 to 2020, which is great for climate science and other, kinds of projects, which we did. This was one section that I took out, details on this. Given that you all are talking about data science in this series, I would have kept this a little more detail on this project. But there is a paper on it that you all can check. But just a quick look into the approach. We had a female paleoclimatologist work with students on research questions related to climate change. We worked with actual data from the National Oceanic Atmospheric Agency in the US, created data visualizations, students processed lists and data, abstractions for accessing real data sources, tools for visualization, etc. So it really was a coming together of these wonderful disciplines in a very organic and wonderful way. And it was a wonderful project that impacted students' perceptions on computing, etc. A little more detail in this AI ML module of CS Frontiers. It has at its core an examination of ethics and ML and biases. This is a quick look at the curriculum. It sort of draws from freely available tools, etc., moving from AI to ML to examining ethics and techniques, ML techniques, neural networks, etc. Projects like AI and criminal justice, AI and environment, etc. And it's all project-based, and all collaborative work among students, and also we brought in role models, etc., for students to talk, to convey a sense of belonging. And one small project I'd like to describe, activity that students did, was the sentimental writer, where students learn to classify text using this API called Parallel Dots, which can classify any text that you give it as positive, negative, or neutral. And it can also classify hate speech or sarcasm, etc. And so students had this unplugged pseudocode that they sort of then used Parsons puzzles kinds of activities to put the code together. And in their final project, students actually examined biases in New York Times articles or of Taylor Swift songs, etc. And all of these are our, these are a subset of the papers from this project that you might want to refer to. In this project, we integrated AI and cybersecurity, basically AI learning in the context of cybersecurity examples. And here students actually learned to write and examine code for training a classifier. And the context for this particular project that I'm going to share was Twitter data, and the goal was to classify an account as a bot account or not. And students first explored the data through CodeApp, which is a dynamic data exploration tool from within Nets blocks, and examined how various features of data are related to being a bot or not. For example, does it have a profile image, how many tweets per second, and many kinds of features like that. And through a scaffolded activity, students worked in groups to build first a rule-based classifier based on rules that they come up with. And we provided the code for them to actually evaluate the classification code over an entire data set and score how well it performed. And clearly, it didn't do very great, because human classification, rule-based classification along, several features like that can only go so far. But then they proceed to understanding how to automate the process of classification that they did manually through code, which is actually deciding how to split the data. We even sort of introduce the idea of entropy, etc., how clean the splits can be and all of that. And I guess we were doing a lot of code sense kind of things without really thinking about it as code sense. They move, to the Nets blocks environment, and there's another scaffolded activity where we break, the sections into sub goals and Parsons puzzles, give them the pieces based on the pseudocode. They need to put together the classifier and then actually run the whole thing. And or we could just give the data to students to examine, or just run it and build the decision tree. You could work at various levels of ability and interest, and so this was, and then after they've built this classifier, they test it on a phishing data set. So in this sub project, sort of they're doing programming, but it's at a level that is manageable for students. And so a lot of the code is already given to students to just sort of build intuitions of how these classifiers are built, because it gets mathematical at some levels, and this is sort of sometimes beyond the capability levels or what students know at the high school level. So both CS Frontiers and ACT have their curricula, lesson plans, videos, projects, everything up freely available online at these URLs. In fact, a lot of the materials from several projects are online, freely available. It's a growing list of resources on AI4K12.org. I cannot end this section without mentioning the brilliant resource from your own stables, Experience AI, aimed at middle school students, developed with Google DeepMind. And I'm sure many of you already know about it, and if you don't, you must check it out. In the US here, we are sort of engaging in a CS standards revision to basically bring AI more into computer science, and the standards are being revised. It's a long process. We'll see how it goes, because AI itself is moving so fast. Some closing thoughts. There are challenges and tensions in trying to teach AI and bring AI into the classroom. It's a very rapidly changing landscape, and it's very hard to keep up. There are misperceptions about AI in the broader discourse, which makes it that much harder to sort of deal with it in the classroom, because you have to tackle all those misconceptions as well, demystify AI. It's already a crowded curriculum. We all need to rethink our curriculum in order to bring teaching about AI also, or teaching about AI into the curriculum. We need to build teacher capacity. It's at the very core of anything that we try to do. How deep we can or should go. What does AI for all mean? What does AI literacy for all mean? It's all something we're still figuring out. How there's a need for robust evidence and research, and that cannot keep up with this pace of adoption right now. There's so much pressure to sort of bring it to the classroom without adequate evidence. And there's a need for contextualizing AI tools and learning for local and cultural relevance. And on this last point, I just want to say that a lot of the R&D is focused on the more advanced economies. So as we take these learnings to places, wherever, I'm just saying region as a parameter there, what data sets are relatable to learners over there? What tools and classifier examples are drawn from local context? What issues of ethics are more pertinent to that particular part of the world? How can cultural experiences leverage local languages and cultures? And there's a crucial need for proper teacher preparation in culturally relevant AI education. And so all of this takes time. Move fast and break things is not our mantra, even though, this is what Silicon Valley believes in and tries to push on the education world. In a blog post that I authored recently, I advocated for a slower, more deliberate approach. And we have to be clear-eyed about the reality that the pace at which AI technologies are introduced in classrooms has profound implications for equity and accessibility, and a rapid deployment will more likely than not engender a new kind of digital divide and exacerbate existing inequities. And with that, I have one slide on closing. AI should not be a solution in search for problems. Start with building capacity amongst teachers, amplify teacher capacity rather than replacing them. Get them to use AI for productivity tasks, see what makes sense, put it in the hands of adults first. I don't believe in bringing LLMs into the classroom for kids to use without robust guardrails in place. We need to be circumspect and very deliberate about how to mitigate the risks, especially for already marginalized students. And we need to ensure that LLMs are specific to the context in which they are being deployed. And for many, it's very tempting to make students and teachers work with this shiny new technology, but we need to educate them about it first. And so if you ask me which I would prioritize, I think teaching about AI should precede use of AI. It can go hand in hand, but I don't think students should use it without understanding this technology first. And with that, I end. This is the AI briefs that I talked about. There's a webinar on that this Friday if you all wish to participate and attend.
That's amazing. Thank you so much. Can we give a little virtual clap? That's jazz hands or whatever. That was amazing. Thank you so much.